From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. This episode of Fragmented has been brought to you by Rollbar. With Rollbar, you can catch code errors before your users do, because I don't know about you, but the last place I want to find an error is inside of a 1-star review on Google Play. That's just pretty much the worst case scenario, because getting those 1-star reviews to go away is really problematic. So the next best thing is actually preventing them from happening. So if we can prevent those errors, even better. Rollbar will help you do that. The cool thing about Rollbar is they work with all your existing major languages and frameworks. And to really tie this together is they work with your Android application, so they're bug and crash reporting, all that kind of good stuff, and they can also do this on the server as well. And then you can tie that together. So knowing this release X of the Android app and release Y of your Rails API, this perfect storm is happening, and you're getting these errors. It's easy to track those things, much easier than it would traditionally be if you didn't have a solution like Rollbar. The cool thing is they also integrate with existing things like Slack, so when I do a deployment or have an issue that comes in, it automatically notifies me inside of a Slack channel, which makes it really easy for me to see what's going on, especially if there's something that's really high priority. I'll know immediately because I'll be getting a bunch of alerts, and it's time to go fix it and check it out. Rollbar is used by a bunch of companies. Kaushik uses them, I use them, but there's also folks like Heroku, Twilio, Kayak, Zendesk, Twitch. The list goes really on and on and on. Now, if you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening, and thanks, Rollbar. In this episode of Fragmented, we talk about how you can learn and approach a code base of an already written application. Applications have been around for a long time at this point for Android. How do you come into a new company and feel productive? How do you know where certain screens are at? How do you know what different types of features there are in the application? How do you identify them? How do you add a feature when you don't even know where the application is? And how can you be certain that whatever you're going to change isn't going to break anything else? We talk about all that and a whole bunch more in this episode. We hope you enjoy. Today on Fragmented, we're going to talk about how to learn or approach a code base of an already written existing application. I like to really rephrase this as how to work effectively with legacy code. Android has been around for quite a while now. We're approaching the 9, close to 10-year mark that Android's been available. I've been writing code in Android since 2008, so some of my code is almost 10 years old. That's code that's well over a long time ago. There's a bunch of patterns and practices, things that have changed many times over the course of Android's ecosystem evolvement. So how do you hop into one of these applications? Let's say you join a team. This application has been around for years. How do you hop in there and approach this code base so you can actually become productive in a timely fashion and start providing value right out of the gate? Now, I've been consulting in software for close to 15 years now and been in software for even longer than that. I see many different applications, code bases on every year, multiple different applications, multiple different source sets from different companies. Some are in fantastic shape, some are in various states of disrepair. Unfortunately, the majority of them that I see do need a lot of work. Now, really before we start hopping into this, what I would really like to do is define my definition of legacy code. And I can't take full credit for this. It's a definition that I've actually taken from Michael Feathers, who I highly respect. Now, Michael Feathers is well known in the software industry. If you're not familiar with him, please Google him. He is the author of one of my favorite books on software. And the name of that book is Working Effectively with Legacy Code. Now, if you don't have it, what you need to do is take a look at the show notes. We'll provide a link to where you can go check it out on Amazon. Buy the book. If you have it, a physical copy is really what I recommend. And the reason why is because it's full of just chock full of just great details and great information. Now, I picked up this book in 2005. This book came out in 2004. So at this point, this book is close to 13 years old. However, don't discount it for that. This is one of those seminal gems in the software industry. It applies to every language. Now, the examples are in Java, which is fantastic. But when I read it, I was doing C# development, but it still made sense to me then. all of the principles, all the practices apply to all languages and all programming aspects. So it doesn't matter if you're doing Java, C++, C, Ruby, Python, JavaScript, it doesn't matter. All of these principles still apply. Now, one of the reasons why I picked up this book is because I walked into a company back in 2005 who had some really old Visual Basic code, and it took me weeks to make changes, and I was really frustrated. And I actually happened to run across this book through some forum while doing a bunch of research. And the thing that caught my eye are a bunch of the chapter title names. And let me read you a couple of the title names from the book, Working Effectively with Legacy Code. Chapter 6. This is the chapter title. I don't have much time and I have to change it. Yes, that's literally the name of the chapter. Chapter 7's title, It Takes Forever to Make a Change. These are starting to sound very familiar. Chapter 8, How do I add a feature? I don't know how many times I've been there. I show up to a new client. I'm like, I have no idea where to start, how to make a feature. Chapter 9, and this is the big one. This is a good one here. I can't get this class into a test harness. This is a very repeatable thing that I see all the way till now. I can't get something under test. It's very difficult. These chapters outline how you can actually implement all these different types of things, how to get your classes into test harnesses, how you add features, how to make changes, and so forth, how to break dependencies. Here's chapter 11. I need to make a change. What methods should I test? Here's another one, chapter 12. I need to make many changes in one area, which is probably very familiar. And number 13, which is one of my favorite titles, is I need to make a change, but I don't know what tests to write. So he breaks this all down for you, and he even goes even further enough, which is chapter 16, which is like a second favorite one here. It says, I don't understand the code well enough to change it. And that's usually kind of the big thing here, is you're going to get into a new application. It's been written many times ago. It's been touched by tens, 20, hundreds of developers. Depends on the company that you're working for. How do you get your head around this application's code base? Now, this is something that I have kind of started perfecting, and there's basically a 3-step process in which I go through to do this, and this is very easy to follow. Well, we can say 4 steps, and step 0 is go buy the book by Michael Fetters, physical copy, keep it with you on your desk at work or at home. Step 2, put it on your Kindle. Step 3, have it on your Kindle on your phone. Just kidding. But anyway, make sure you have a copy of that book is kind of just a prereq for this, because it's just fantastic. And it gets you to change your mind about the way things are. Now, the definition of legacy code, as Michael Fetters describes it, as I was beginning to say, is one that I use. And it's one of my favorite quotes out there. And this is paraphrased here, but basically, Michael Fetters states that legacy code is code that does not have tests. So if you think about that for a little bit, if we just go with that definition, it means that if that code doesn't have a test, then it's already legacy. So that means if I write code right now with no test, it's legacy. Well, why is it legacy? Well, because we have no way of verifying that we know what it does. So all we're really saying is we need some type of test that executes that code path to make sure it does what it's expected to do. Otherwise, it's legacy. It could be a bug. It could be something else. There's an evergreen debate always going on that that's not what legacy code is. Just because I have COBOL with some tests doesn't mean that it's not legacy. I understand and respect that argument. This is just a higher level statement of look, if your code does not have tests, it's legacy. So let's think about it in that regard. So how do I approach it when I'm going to a new client? So let's take that consideration. And I come in, I have a company that have a large problem. For example, they're having problems, maybe just making changes takes forever, and they need someone to come in to really help fix things. How do I wrap my head around it? So step 1, when I walk into a new company, this is what I recommend everyone do. You come in and you review and run the app. This is really the general step. Is if you have an Android app, you install the application, you're going to run it, you're going to go ahead and interact with the screens. If you need a username and password, make sure you obtain one of those that has all the features. Ask certain questions. For example, if there is a username and password, are there different user levels? Is there a standard? Is there a silver and gold and platinum customers that can use this different application? Do they have different features? And so you need to ask those certain questions while you're reviewing and running the app. And so that's going to actually expose possible different code paths that you may have not known about, because I've been in various situations where I think that I know the application, and all of a sudden the product owner will say, yeah, well, if you hit this deep link off of this one thing, then you're going to get, and you're a premium customer, well, then you're going to get this customized experience. So you need to ask these questions. Are there different experiences for different users? Okay. What about user state? If a user's in a particular state, maybe they have gone through a particular set of actions, then they get a different experience. So ask those questions. Is there a different experience for those users? If there is, obtain the login credentials or example credentials for each one of those users so you can examine that. And then from a user perspective, hop in and start playing with the app. Make sure you understand what the app is supposed to do. If you're in the fitness industry, what does the app do? Does it teach you how to perform a workout? Does it do calorie tracking? Does it perhaps maybe do something different, like coaching exercises? What does it do? Make sure that all of those questions have been answered. And you're going to need to talk to the product owner, the CEO, or whatever. Now, if you're unsure and they can't really answer those questions, this is going to be a really difficult task, but it's going to be one that's just going to take a lot of time and so forth. And we'll kind of get to that in here in a second. So once you have all of your users and you're able to actually run the app, you want to make some notes when you're kind of going through the app. Okay, when I go to this screen, if I log in as a platinum user, the background color is a red color. So I log in as a standard user, it's blue. So it looks like we have some type of theming going on. So we know we need to figure that out later on. And just kind of make a bunch of notes. Each application is going to be different. So there's not really a set of standard rules here that are going to apply. The main thing for number one is you're going to want to make sure you have the various different users that can have the app and understand the different state the app can be in, and then actually see it in your hand and actually interact with it, see how it works, because you're going to see things that you wouldn't see in the code. For example, okay, this animation works, or for some reason, this spinner is halfway off the screen over here, or for whatever reason, there's different themes that are running. And that stuff's very hard to see sometimes just from looking at the code, especially if you're looking 80, 100 or more different screens, or if these things are dynamic in nature as well, which is also a good question to ask. Is any of this application powered from a remote endpoint? Is anything dynamically generated? And then make sure you walk through those. Now, if you have the different users, you're going to be able to do that. Now, number two is you're going to be just looking at the source. Now, here's how I recommend doing it. Just so I can really understand the application, I'll find the entry point of the application. Usually this is going to be the application class if there's a custom application, or it's going to be the default activity. Now, please note, there's a couple of different entry points inside of applications sometimes. Sometimes you're going to have them in receivers. Sometimes you're going to have them in application object. Sometimes they're going to be inside of Android activities. And sometimes they're going to be through some various different types of deep linking. So you're going to have to go ahead and open up the Android manifest, start inspecting to see what's in there. Now, if the Android manifest looks like a complete mess, usually what I'll do at that time is I'll just take all of the activities, I'll group them at the top, then I'll group receivers, and then I group services, just so I have at least some type of common formatting. I can't tell you how many times I've walked into an application and seen just a complete mess. So try to get a little bit of organization if you can. So now that you have the entry point, let's just say it's the first main activity, kind of what you want to do is set a breakpoint, fire the application up inside of Android Studio, start walking through the application, see where everything goes. When you log in, what class is hit from the login? Is that login done inside the activity? Is it done inside of another class? Is it using retrofit? Is it using volley? Is it using something else that you're not familiar with? Kind of step through all of the code that you can as you're using these features. This will really give you a good idea of like, oh, okay, so if I hit this button, it's going to take me to this screen. If I hit this button, it's going to take me to this screen. Okay, I see what's happening here. Oh, this has a presenter. Oh, this looks like a new pattern. Okay, all right. Which also kind of takes a look at, all right, now you've kind of familiarized yourself with a little bit of the code. You can look at maybe the get logs. Okay, what's kind of changed, in the last 6 months? And that may be a lot. If you're in a huge company, that may be impossible. But take a look at the last few weeks, if you can, of commits and see kind of what's been changed. If nothing's happened since then just take a look at the last few pages of commits and just look at the messages. Hopefully they're good messages. Usually they're kind of funky. So I usually rely on just stepping through the code myself, but it does kind of give you some insight if perhaps the developer left you some good tips. Now, here's the tip here is don't step over anything. You're going to want to step into everything. When you're in the debugger and you're debugging through those entry points in the login, don't step over anything, because you may see something that's like RX Java and it says like, okay, you're going to say something like as observable, which is a common term if you maybe are using a subject or something like that in RX Java. If you're not familiar with it, don't worry. This is just kind of just common, stuff here. If for whatever reason, whatever object has a method that looks familiar, like, oh, .toString, step into it. And why do I say that? Because what you think may be a built-in platform Java or Android specific thing may be actually overridden somewhere else in some custom implementation through some inheritance hierarchy. So you need to step into it, see where that class is located. All of a sudden you're inside of the toString object for some Java class that's in the Java standard library. Well, then okay, I don't need that. I can step out of that. But if you step into something like a toString method and all of a sudden you're in some other custom class in the application, that gives you visibility into the app that you had no idea about before. Oh, for some reason, the customer class has a custom toString method. Well, kind of get you thinking, why is that? And you can make more notes about this and start evaluating. This is going to take a lot of time. Now, usually what I recommend when you're going through these steps, give yourself, it depends on how much time you have really, but the more time you can have, the better. But at least a minimum of a day to go through all this application. A couple of days if this application is very large. Start stepping through all the different parts. Make notes as you're going through this. Okay, main activity goes to dashboard activity. Dashboard goes to report activity. Report activity has a view pager. All that kind of stuff. And then you kind of start building up this mental model. But stepping into everything is key, because if you step over it, what you think might be standard may actually be a custom implementation somewhere. And I can't tell you how many times this has burned me. Now, that's number 2. We've looked at the source. We've ran the app. We've looked at the source. We feel kind of comfortable with it. Number 3 is the real big one here. And that is look inside the source code and see if there's tests. And if there are tests, see what these tests cover. This goes back to the definition of working effectively with legacy code. Android has had a notorious problem for being difficult to test. It has gotten easier over the years with improved tools like Espresso, the Espresso test recorder. We have JUnit where, people are following different patterns like MVP, MVVM, and so forth. So those things are helping. But what's really going to set the stage apart are there tests? And if there are tests, you need to run them. This is where it kind of gets a little edgy and scary, because if you run those tests and all those tests fail, well, now you have to go dig in, and it's going to take some more time with the product owner or whoever. You say, all right, well, there's a test that does this, this, and this, and it's supposed to verify X, Y, and Z, but it's failing. Should the application be doing X, Y, and Z? You're going to need to verify all those things for any of those tests that are failing. It's also good to re-verify and sit down with the product owner and say, hey, look, here's the list of tests that I have that seem to verify some type of business behavior. When a customer is upgraded from standard to platinum, then they should have access to A, B, and C. You'll need to verify that. Is that still correct? Because there could have been a change since the last developer, or the last developer forgot to implement it. And they say, oh, actually, they need access to A, B, C, and Q. And that wasn't in there. And so you need to know to update those different things. The tests are going to be the really huge area that's going to cover you, because as Michael Feather says, this is a very good analogy here. Imagine you had your source code is an ocean, and it's just this huge ocean, right? Well, if you are out in the middle of the ocean and you're not in a boat, well, it's pretty dangerous for you. You're kind of floating out there. You're going to, you could die very easily. So what is a safe location for you? Well, an island is, right? So if you could swim over and sit on an island, well, that's a safe place. Well, think of a test as an island. So if your source code is an ocean and the test is an island, well, that's great. Well, the more tests that you have, the more islands you have, and the more contiguous that landmass becomes, and the safer things become for you. Now, it's kind of a high-level analogy, but what that really means is that if you change something, you can run the test, of course, and verify you didn't break anything, because there's still a lot of this application you think you may understand from going through steps 1 and 2, but you still maybe don't, because there's always little weird hidden gems here and there that we're going to identify throughout time. So those are the first 3 steps that really kind of get me going. This is kind of the whole 80-20 rule right here. This is the 20% of the work that's going to get you the 80% of the benefit right out of the gate. And this is going to make you productive, going to get you familiar with the source code, know where to start, where the entry points are, and how to basically interact with the application and what's there. That in itself, when you have that, you're already ahead of the game. Now, let's say that you're there and all of a sudden your client or your boss says, hey, I need you to, on this screen, add this button and add a feature, right? Well, for some reason, you don't even know how to get to that screen or where that screen is at in your code. Now, you can open the app and you can navigate to it and you can tap all these things and it gets you to that screen, but you have no idea what that activity, fragment, view, whatever it is called. You have no idea how to find it. And I can't tell you how many times when things are poorly named and I can't find them. What I will do is look for a string that is on that screen. It could be a button, could be a title, could be anything that's on that screen that looks something that I could maybe go off of. And so maybe I would say customers, first name, or customer joined at, and maybe the day they joined the company or something like that. I'll take that string and I would just open Android Studio and just do a Command Shift F, which is a find all. And I would paste that string in there. I try to find that string inside of the application. And what that's going to do is if I'm able to find it, it'll find it either in the strings file or it's going to find it in the view or in a Java file somewhere. And then I can start back tracing from there. Now, if it's in a strings file, I'm just going to go ahead and find usages, right click, find usages on that string to see where it's used. Hopefully, the application developer is using good string habits, not reusing the same string everywhere. But that's usually the case, is strings are reused a lot of the time. And then I'm going to have to find out which one it is from there. But it'll at least narrow it down if I have a ton of classes. That's really, really useful. Now, secondly, while we're also looking into our application, we may have been through steps 1, 2, and 3, looked for our tests. We're able to identify things maybe through strings or even looking at images and kind of guessing some file names and just kind of hopping back and forth. You're going to want to look at the application structure as well inside the app. How is it formatted? Is it inside of one package? Is it inside of multiple packages? Are we using a libs folder? Are we using Gradle properly? Inspect all those things so you know where your dependencies are coming from. Now here's the thing too, if you're inside of your application and you see that there's a libs folder or there's custom modules pulled in and it looks like something is not being pulled in by traditional Gradle methods, you're going to want to ask really important questions. Do you know if this library was custom modified and dropped into the library folder? Because maybe they had to make a change for it to work with their scenario. And if you changed it to work from the one from Gradle, from Maven Central or JCenter, it may break the application. So you're going to have a lot of questions to ask. Now, also, when you're looking at that source code, you think you have it done. One of the final steps I really like to do, and this is just kind of a completeness step, is open the Android manifest and then go and find out where all of these activities are used. And if you haven't seen this activity used anywhere, then you need to ask the question of how do I get to this screen? And what I mean by that is you may be looking in the manifest and you'll see something like customer service activity. And you open that activity and it's got some strings in there. And you're like, wow, I've never seen these strings on the application when I used it. You're going to have to ask how you get to it. And again, it may be through some weird custom implementation that you didn't know about, that they're using a third-party deep linking technology that deep links into that particular activity for whatever reason. If you don't look at the manifest and inspect those activities, you just simply won't know. So again, this really kind of goes back to looking at the screen, looking what's in the code. Is it, looking for a string? Where is that string used? Have I seen that string before, etc. Now, finally, what I immediately recommend folks do is, if they don't have any crash reporting software, install the crash reporting software immediately for the next release. This, again, is just kind of common knowledge, but it's going to help you be very proactive for fixing crashes. Now, that's how you're going to hop into the actual code and actually get started with it and kind of get familiar with it. How do you actually start providing value? This is where the actual book, Working Effectively with Legacy Code, comes into play. When you need to write that new feature, the first thing you need to do is actually try to write a test for it. Sometimes it's impossible to write a test for a particular environment based upon it's hitting an API, it's doing something different. You may have to look at using something like mock interceptor mock web server from the OK HTTP team and actually provide a mock endpoint to return the data, or something like WireMock, depends on what you're using, so you can actually start simulating live tests. What I usually recommend is writing, if you can't get this into a regular JVM unit test where you don't have to include Android, then write an espresso test that just verifies that this screen does still what it does. And as I log in, I can get to these fields. This initial setup is going to take a long time. Unfortunately, if you don't have the time and budget, it's going to be one of those difficult things to see if you can actually write these tests. If you can, convince the client to do that, convince your boss that you need to write these tests. A lot of times, I recommend just don't even say anything about the test and start writing them so that these errors don't happen again. Build that into your estimate because this is in a bad state and we want to fix it as soon as possible. In the end, what really matters is tests. Do we have tests that cover our application? And if you really need to learn really about how to start testing your application, you'll need to start looking at different patterns. MVP, MVVM. How can you actually pull the server out so it doesn't affect you anymore? Is it going to be with mock web server? Is it going to be with WireMock? Is it going to be with something else? These are tools that allow you to simulate a real server interaction, but you actually get to script the responses. So your tests can then execute in isolation. You don't actually need the server to respond. And furthermore, you can actually have your server respond with invalid responses or things that you wouldn't expect to happen, so your application responds accordingly. So recap, number 1, review and run the app. Number 2, you want to look at the source, dive into the entry point of the application, kind of step through it with a debugger, and you want to step into everything. Don't step over it. And number 3, look at the source for the test and run the test, see if you can identify it. And as ancillary items, look at the manifest, check out all the activities, see where they go, see where maybe the receivers go, see where all the entry points of the application software are, install crash reporting software, and when you start writing that new feature, write your tests, because that's what's going to save you. I hope that will help you. Until next time. This episode of Fragmented has been brought to you by Rollbar. Rollbar is used by a bunch of companies. Kaushik uses them, I use them, but there's also folks like Heroku, Twilio, Kayak, Zendesk, Twitch. The list goes really on and on and on. If you'd like to check out Rollbar, you can go to rollbar.com/fragmented and you'll get the Bootstrap plan for free. Again, go ahead and check that out at rollbar.com/fragmented and you'll get that Bootstrap plan for free. Thanks for listening and thanks, Rollbar.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.